Thank you for joining us today. We are happy you are here and we are excited to share another exciting show with you. Welcome to the Tech and Space Leader Show, where we learn lessons from founders of companies of the next frontier. I am your host, Lisa Dreher, and I'm really excited to introduce our guest for today, Lee Rosen. He is the co founder and CEO of ThinkOrbital. Welcome to the show, Lee.
Thanks so much, Lisa. Really glad to be here and look forward to an exciting chat we will have.
Fantastic. Maybe we can start by having you give us a little bit of background on yourself and Think Orbital.
Oh, my favorite topic. We can talk about myself. Excellent. I served for 23 years in the United States Air Force, really the Space Force piece of the Air Force before there was a Space Force. Retired in 2010. I was a space engineer, acquisition officer, and operator. Did multiple tours at the National Reconnaissance Office, at Space Systems Command in Los Angeles, and had the opportunity to command at both launch bases at Vandenberg and at Cape Canaveral. While I was at Cape Canaveral, I had the opportunity to meet this guy named Elon Musk. You may have heard of him once or twice. Uh, this was back before Elon was Elon, and they were building a new launch capability at Cape Canaveral, and President Obama was coming down to the Cape, and I was asked to give the president a tour. And the big boss, the four-star general, said, "Well, where shall we take him?" And I said, "Well, we could take him over to that beautiful new Atlas pad. Just built it. It's really nice. They do like one or two commercial launches a year. He's coming down to announce a commercial space initiative. Let's go do that." And the big boss was like, "Nah, why don't you take him over to those new guys at SpaceX?" And I'm like, "Oh, geez, sir. They'll blow something up. He'll fall in a hole. This will be career limiting for both of us. Maybe we shouldn't do that." But anyway, the four-star beat the colonel, and we ended up going over to SpaceX. And while waiting for the president to show up, it was pretty much just me and Elon in this hangar. And he was asking me all kinds of crazy questions about, how would you land a rocket? What do you do with a rocket after you launch it? Do you know any other mode of transportation that you throw away after one usage? And I said, boy, these are very interesting questions. And we started talking about parachutes and things like that. And he's like, well, parachutes don't work well on Mars. And I'm like, wow, this guy is either crazy or brilliant. And turns out he was brilliant. And not long after that, I decided to retire from the Air Force and, you know, really thought that we needed to do something different in launch because all of our space capability and launch capability had pretty much been offshored to our good pals, the Russians and the French. And, we really needed to have some indigenous capability here, and prices were going up and warfighters were getting less capability on orbit because of the cost increases. So there had to be competition induced, and I saw this as a great opportunity to have competition induced. Retired, applied for a job at SpaceX, was fortunate enough to get selected, had the opportunity to lead the first build of the Vandenberg launch site for both Falcon 9 and Falcon Heavy. Then Elon asked me to come down. I ran launch operations and mission operations for a total of 11 years at SpaceX, and got to do some amazing things from launching Falcon 9s to Falcon Heavies to cargo to the International Space Station to 22 good friends into outer space and bringing them home safely. And then kind of still had this entrepreneurial bent and did the dumbest thing anybody who has failed retirement twice could do, and started a space company called ThinkOrbital. So I will, that's kind of where we are today. How's that, Lisa?
Wow, what an amazing career, and it's continuing. So apparently whether you like it or not, right? So tell us about the biggest gaps that Think Orbital is fulfilling.
Yeah, so we really started out as a space infrastructure company, right? If you think about all of the constraints of outer space, right? There's getting to outer space, which at SpaceX we were able to pretty much eliminate that constraint, right? We went, now launch is reliable, it's affordable, it's super high cadence, all the things we had ever dreamed of, right? And this call is coming to you over Starlink, right? So for $100 a month, you can have data pretty much anywhere on the planet. So there's another constraint that's been wiped out. And in our estimation, the next big constraint that we have to overcome is the size of things in outer space, because everything in outer space is tiny compared to any terrestrial application. You'd never build a factory on the ground that's like 40 feet long and 15 feet wide, because it has no scale. So in order to do that, you have to build things in situ, big things, right? Don't build the Empire State Building in New Jersey, put it on a truck and take it to New York City. You have to build those things where you need them. So we figured out a way to build not just big things in outer space, but the tools needed to build big things in outer space. And on 2 launches, we've demonstrated a technology called electron beam welding. And electron beam welding sounds like it's from the future, but it's been around since the 1960s. It's used extensively in the nuclear industry. It was used at SpaceX to weld the thrust chambers of the engines together. We've taken a welding tool the size of your desk and shrunk it down to the size of a coffee cup. Now, we don't have to weld through 12 inches of steel in outer space, but welding through half-inch aluminum is not a problem with this little gun, which is way bigger than pretty much any structure in outer space. So we had a great opportunity to demonstrate that. We, won a few small business innovative research contracts with NASA and the Air Force on that, and the Space Force. And then we realized the first rule of entrepreneurship, that if you don't have a customer who's willing to really invest, you die. So we chose the not die route, and did a little bit of a shift to another fundamental piece of the electron beam technology. And it turns out that when you go to the dentist office and you stick that thing in your mouth and they point that nasty tube at you, it's really an electron beam gun hitting a piece of high density metal, usually tungsten, to generate x-rays to get pictures of your teeth. So we're like, wow, we know a little bit about electron beam stuff. Let's get a piece of tungsten. And lo and behold, we were able to generate x-rays using our welding gun. And we were able to x-ray the welds that we were doing. We're like, that has some interesting implications to be able to do weld inspection, which is the primary mechanical way you inspect welds. But then when we were doing some of that inspection, we could actually not only see through the weld, we could see beyond the weld and see into the interior of the thing that we were inspecting. And I'm like, I had run back when I was in the Space Force or Air Force, the counter space program, which included some space domain awareness stuff and offensive and defensive capabilities. And it occurred to me that being able to look inside something would be a very powerful capability. And being able to look inside a satellite to see what its constituent parts were, how much fuel it had on board, what the size of its tanks were, if they're hiding any capabilities, say like the Russians hiding nuclear weapons inside satellites, would be a very important capability for national security. So we got asked to come up and brief the National Space Council last summer. And they're like, wow, that's cool. How far away do you have to be? I'm like, well, you have to be in pretty close proximity, a couple meters away to be able to generate the x-rays, and then on the other side to catch the x-rays with a detector. They're like, that's a pretty provocative act. How far away could you be? And I said, I don't know the answer to that question, but let us go do a little bit of math and some analysis. And it turns out that the math closes and the link closes at over 10 kilometers away to resolve an image that has about 5 centimeter resolution inside of a satellite. And those are 2 important numbers, 5 centimeters being the smallest nuclear core that's ever been built, and 10 kilometers being kind of the international water line of space. If somebody crosses inside 10 kilometers, they're up to no good, and you're probably going to start maneuvering away. So both of those turned out to be important numbers, and we've won 3 contracts now with the Space Force, including a tactical funding increase to demonstrate this terrestrially, and we're in the process of doing that right now.
Oh my gosh. Okay, that is so much to unpack. That is amazing. So, I mean, we're talking about everything from building things in space to, I guess, investigating things in space.
Correct. Yeah,
Yeah.
it's really a waterfront of interesting things, all revolving around this one technology. So trying to remain somewhat focused, but kind of go where the customers are, frankly.
Absolutely. So it sounds like there's a lot of different use cases. How does, I guess, this being able to see what's happening inside of other satellites that are orbiting Earth, how does that support warfighting efforts on Earth?
Yeah, there have been some very interesting cases, and the way we do space domain awareness today is basically we look at a bunch of dots coming across the sky, and we say we think that that dot is this adversary capability, right? Now, and we do our level best to keep what they call track custody of these individual dots. Now, that doesn't give you a whole lot of information about what that dot is, what its intent is, or kind of what capabilities it might be hiding. Um, if we're really interested in it, there's an unclassified program called GSAP, the Geospatial Space Situational Awareness Program, that can get pictures of stuff at geostationary orbit, right? But again, that's kind of a picture of the outside of a satellite. A lot of satellites kind of look the same. I can tell maybe what their data rate is. I can listen to the satellite. I can get a picture of it, but would you feel safe getting on an airplane if the TSA guy said, yeah, I'm going to just look at the outside of your luggage and listen for a tick, tick, tick? Probably not, right?
Right.
So, turns out we want to inspect to be able to see the inside to really understand the contents, the intent, and the type of detector that we use is similar to a TSA detector in that the reason you have to take water out of your luggage when you go through the TSA line and everybody complains about it is that they absorb X-rays in a very different manner and can hide things that are underneath it, like explosives. So that's the reason they make you take the water out of your bag, and that capability to be able to identify the material characteristics is another thing that we can also do to know if they're hiding high explosives, plutonium or uranium, or that there's other interesting structures inside that adversary capability. So it helps us really fill in the missing piece of space domain awareness, which is, what is that thing? What do they intend to use it for? And what are its capabilities?
Right, right. One of the things that I noticed is you're talking about also the in space assembly. Can you tell us a little bit about the Think platforms that ThinkOrbital is bringing to market?
You bet. So again, the ability to build big infrastructure in space, we think, is the key to the new space economy because there's no way to scale anything in space. And there are a lot of folks that are starting to get into the manufacturing of things in outer space and mining asteroids and all of those different type of capabilities, which is all amazing technology. But they have to have a place to be able to do this at scale for it to be economically efficient, right? So we came up with a great concept for actually building huge infrastructure in space. And if you imagine a soccer ball, right, made up of pentagons and hexagons, if you were to unstitch that soccer ball and stack it flat, you could get a lot of material in a very small area, right? So the concept is unstack the soccer ball, stack it flat, IKEA style, stuff that in a rocket, and then launch that and then reassemble the soccer ball in outer space. Now, we've done one small business innovative research contract with the Air Force to show robotically how you would reassemble that soccer ball using two walking robots, which is technology we have today. Basically, we would latch those pieces of the soccer ball together mechanically to get good alignment. And then, lo and behold, use this thing called electron beam welding that we've been developing to kind of weld the seams together to make it rigid and to make it airtight. Now, that gives you a big empty volume in outer space. And we're going to work with other folks who want to do pharmaceutical manufacturing, military missions, tourists in space, all of those kind of things. And just to give you an idea of the size of this thing, on a single Starship launch, we can launch 4 times the volume of the International Space Station and assemble it in about 8 weeks, right? When you have that type of scale in outer space, it changes the game for this new space economy that we all want to come to fruition, but is lacking this fundamental infrastructure capability.
Right. Oh my gosh. Okay, so this is amazing. When are you expecting additional missions to come up? When are your next missions?
So we've got a mission on the books for February of 2026. We're going to be launching our X-ray detector up into space on the 26th of, or in February of next year. In the summer of next year, we're launching our X-ray source and focusing mechanism. Those 2 satellites are going to do a rendezvous about 1 kilometer apart, and we're going to shoot X-rays back and forth. And I'm trying to convince the government to let me get a satellite in between those 2 to get an image of the interior of a satellite. So a really exciting capability that we think will open a lot of people's eyes when we get that first image.
Absolutely. There was something earlier that you said that made me want to ask, are we talking only in low Earth orbit, or are you also, because you mentioned something about geo as well and being able to do that. So what orbits are we talking about you working in?
Yeah, we are pretty much orbital agnostic. In order for our stuff to work, we just need kind of a microgravity and a vacuum. So space has a lot of that. And, the tests that we're doing in February and summer start out at LEO and then go up to GEO. So,
Okay.
yeah, all orbital regimes are on the table here for both the X-ray stuff and for the in-space construction and manufacturing.
It's very exciting. What is really your long-term vision for ThinkOrbital?
Yeah, the long-term vision is that, Lisa, you get to go vacation at the ThinkOrbital Hotel in low Earth orbit, and you get to have your hotel furniture built in the Think Platform Manufacturing Center, and we're producing things on orbit that we can't produce here on Earth. We're taking dirty industries and doing those things in outer space. And we see a world where space is just another medium. It's not this special place that we all kind of hold sacred. It's another place for us to live, work, and play.
Yeah, absolutely. Okay, so of all of these things that we've talked about, because there's a lot of different capabilities that you have covered today, what excites you the most about the future for Think Orbital?
Boy, as a former retired military guy, I have to tell you, um, the fact that space has now become a warfighting medium, um, and maybe it's not an excitement piece, but I think it's an importance piece more than anything, is that we have to do a better job of, being able to protect our assets in space and maintain the United States asymmetric advantage that we have. I mean, can you imagine a day without GPS, right? Um, and that affects everything from the banking system to targeting systems to being able to find your grandma's house, right?
Yeah.
And we take that for granted, and we no longer can take that for granted, and we have to have the ability to protect and defend. And unless we know what our adversaries are up to in outer space, there's no way to defend against those capabilities.
Absolutely. Okay. So if someone wanted, oh, actually, I want to jump into something really quick. You had mentioned, or I'd seen something about drones. So tell me about this drone aspect of what you're doing.
Yeah, very kind of new development. So we were having a discussion with DARPA about X-ray image processing because they do these big X-ray machines like at the entrance to bases and things like that, where you can have a truck drive by and get an X-ray image to see if there's anything hiding in that truck. They do it at the borders and things like that as well, right? And I got my head scratching about, wow, if they are doing X-rays terrestrially, why can't I take this gear that I built for outer space that can do 10 kilometers away in outer space and try it on the Earth? Because it's small, it's lightweight, it's portable, it's rugged, all of those kind of things. And turns out that X-rays don't propagate as well in air, so there's no way to do it physically at 10 kilometers. But between 10 and 30 meters away from a target, um, we believe that flying these things on drones and looking inside trucks that are driving towards checkpoints or inside buildings, even for troops that have to go in and clear a building to know kind of if there's bad guys inside, is a real possibility here. So we think that this could save a lot of warfighter lives. And hanging it on drones also has some great commercial implications, like inspecting wind blade turbine blades, right? Wind turbine blades, rather. Like they have damage from delamination on those turbine blades. They're a pain in the neck to try to really see. There's wires that run down each blade. You can't really see inside. So the ability to actually look inside some of this energy infrastructure, like pipelines and things like that as well, from an inspection perspective, really exponentially expands our marketplace. So I'm pretty excited about that, and gives us the opportunity to really do some important things for both our military and commercial customers.
Oh my gosh, that is amazing. So for our investor audience, are there updates on where you are in terms of funding?
Yeah, thank you for asking about that. So yes, we're in the middle of our seed round. It's a $3 million seed round. We have a lead investor, one of our longtime investors that's been with us since the beginning, TFX. They're a veteran founder focused fund. Great folks there. And we have several other folks who get about half that round subscribed right now, and always looking for great partners to help us take this thing to the next level.
Fantastic. Okay, so if someone wants to learn more about ThinkOrbital, what should they do?
Well, first of all, there's all kinds of social media stuff, including our website, thinkorbital.com. We are very active on LinkedIn and the other social media platforms, so keep an eye and follow us there. And great podcasts like Guide Force are doing things as well. So, and always happy to chat with anybody who wants to learn more about what we're doing.
Super. Well, Lee, thank you so much for making time to be here today. This has been a fascinating conversation. We would love to have you back as your missions launch and get out into space and learn more about how all of those programs come together.
Great. Thanks so much, Lisa. It's been really a pleasure.
Absolutely, my pleasure. And I do want to take a moment to thank Guideforce for hosting these sessions. To learn more about Guideforce, you can visit guideforce.com. And we'll see you next time on the Tech and Space Leader Show. Thanks again, Lee.
Thank you.